Hello everyone. In this video, I want to answer a very important question, which is how can we learn the mathematical foundations of machine learning and AI very fast, given that AI is a rapidly evolving field. Although there are so many textbooks out there, in my opinion, the best textbook is Mathematics for Machine Learning. The first reason is that this textbook is available for free, so you can have access to the PDF of this textbook. And the second reason is that it's very brief but explains the main points very well. So if you look at the first part of this textbook, and this is my personal recommendation to mainly focus on this first part, we talk about linear algebra, which is very important. Also, extensions of these, such as norms and inner products and orthogonality, which comes under this analytic geometry. Then we learn about how we can work with vectors and matrices, especially in terms of matrix decomposition techniques, like eigenvalue decomposition or other decomposition techniques that you need to know when working with machine learning and AI problems. Also, you learn about derivatives and gradients, and in particular, vector calculus. Also, this textbook covers topics related to probability and distributions, which are very important when you're working with uncertainty in neural networks and also the ways that we can evaluate the performance of AI models. Also, this textbook very briefly talks about continuous optimization, mainly through the lens of gradient descent and some basics of optimization. So if I show you the PDF of this textbook, so you will see that now a more detailed view of the contents of this textbook. In the linear algebra part, it talks about systems of linear equations, vector spaces, linear independence, and rank. Also, we talk about norms, inner products, orthonormal bases, and also orthogonal projections. These are very important topics when you want to learn how deep learning models work. A lot of these are based on matrix multiplication, different types of projections, inner products, and dot products. It's also a great idea to learn more about matrix decompositions, in particular eigenvalue decomposition, Cholesky decomposition, diagonalization, and most importantly, if you want to know only one thing from this chapter is the singular value decomposition or SVD that appears a lot in machine learning and AI. This textbook also talks about vector calculus, starting with derivatives of univariate functions to partial differentiation and gradients, where we use these for multivariate functions, also vector valued functions and different ways of forming gradients, including backpropagation and automatic differentiation, which are the main tools used to train deep learning models. Also, this textbook covers probability and distribution, especially different forms of or families of discrete and continuous probabilities, Gaussian distributions, a little bit about also principles of Bayesian statistics, and eventually talks about optimization using gradient descent and some basics of convex optimization. So these are extremely important topics to learn. And as you can see, this is about 250 pages. So this means that you should be able to go through this part of, or the first part of this textbook in a relatively short amount of time. If you want, you can also go through the second part, which talks about some basics of linear regression, dimensionality reduction. But I personally think that there are better textbooks for those topics once you learn the mathematical foundations. Therefore, my suggestion is to definitely take a look at the first 6 to 7 chapters of this very great textbook called Mathematics for Machine Learning. I hope you found this video helpful.